All right, we're going to do dividing polynomials long division ways. So this is going to take you back to elementary school, and I'll show you what I mean right here. All right, so I'm going to divide this polynomial by m minus 8. So m minus 8 goes into m squared minus 7m minus 11. Again, you can probably bring back some memories with this setup. And now what I'm asking myself is, all right, what do I multiply m by to get m squared? Because I'm trying to find out what I multiply to get this polynomial. So what do I multiply m by to get m squared? That would be m. So now I'm going to multiply everything in this binomial by m. So m times m is n squared, and then negative 8 times m is negative 8m. I subtract, just like I did way back when, m squared minus m squared is 0, and then negative 7m minus negative 8m, that's like negative 7 plus 8, which would give me 1m, and I bring down my remaining term, minus 11, and I ask myself again, what do I multiply m by, this m right here, what do I multiply m by to get m? Well, that's 1. Okay, so that's the other piece of my factor. M times m, m times 1 is 1m, and then negative 8 times 1 is negative 8. So I subtract those. These cancel. Negative 11 plus 8 is negative 3, and that's my remainder because I can't multiply m by anything to get negative 3. So that means that I have a remainder of plus negative 3 divided by m minus 8. That's how I would write my remainder. All right, so what if it's a little more complicated, like something like 14 down here, where I have a few more terms to have to deal with? I'm going to do the same process. So p minus 5 divided into p to the third minus 10p squared plus 20p plus 26. And I go through the same process. What do I multiply p by to get p to the third? P squared. So then I'm going to multiply everything by p squared. So p times p squared is p to the third. Negative 5 times p squared is negative 5p squared. I'm going to subtract those. Those cancel. Negative 10 plus 5p is negative 5p squared. Bring down my next term, plus 20p. Same question. What do I multiply p by to get negative 5p squared? That'd be negative 5p. So multiplying p times negative 5p is negative 5p squared. Negative 5 times negative 5p is positive 25p. Subtract those things. These cancel, and I've got negative 5p. My last term comes all the way down, plus 26. So what do I multiply p by to get negative 5p? That'll be a negative 5. So then negative 5p, and then positive 25. 5 times 5 is 25. Subtract these, those cancel, and I'm left with a positive 1. So then my remainder is 1 over p minus 5. So the remainder, should I end up with something not a 0, the remainder is written as this fraction where whatever the factor is that I'm dividing by is the denominator. So that's long division with polynomials. All right, here's our final example with synthetic division. What I want to do is run you through one of these examples where we're missing some of the terms of our polynomial. If you take a look at this polynomial that we need to find all the zeros of, you see that we're missing the quadratic term. So when we go to write out our synthetic division, we have to put something in its place. So let's kind of focus on that. All right, so the zero that we're going to start with that they kind of got us going with is negative 2. So then if I write out all my terms, 1 would go with my cubic, so that's my highest, but then I don't have that quadratic. So I got to put a 0 in the place of where the quadratic would be. Then I've got negative 12 and negative 16. So I've got something representing each term in the in the polynomial, even if that quadratic term was missing. All right, so now I go through my process just like I had before, but I have this 0 in its place. So bring down my 1, multiply, and I get negative 2. Add those together, and I get negative 2. Negative 2 times negative 2 is a positive 4. Negative 12 plus 8 is negative 8. Negative 8 times negative 2 is positive 16. Add those together, I get a 0. So I've confirmed that it is indeed one of my zeros, one of my solutions. I can rewrite this as x squared minus 2x minus 8 equals 0, and now I can go through my solving process. I'm going to use the quadratic formula. You could factor if you'd like. You could complete the square or whatever works best for you. So this is my A value, this is my B value, this is my C value. So I'm going to go ahead and do x equals opposite of b plus or minus square root b squared minus 4ac, and all of that's over 2 times a. Simplifying underneath my radical, 2 plus or minus square root. That's going to be negative 4 times negative 8 is 32, plus 4 is 36 over 2. So that works out quite nice for me. 2 plus or minus 6 over 2. Now I'm ready for my two scenarios. So x is equal to 2 plus 6 over 2, or x is equal to 2 minus 6 over 2. So 2 plus 6 is 8, divided by 2 is 4. So there's another 0. 2 minus 6 is negative 4, over 2 is negative 2. There's my other 0. So now I've got 3 zeros, negative 2, and 4. Now notice that negative 2 shows up twice. That's a double root. So that means when I go to graph this, there's a bounce at that negative 2. So we talked about bounces earlier this year. That's where that double root is. So totally okay that that showed up twice. And this is how you would represent in case there's a term missing in your polynomial with a 0 right there. Okay, this is a video on synthetic division. So this is a little bit shorter way of doing the long division of polynomials process, and we're also going to integrate it with solving as well. So the directions want us to find the zeros of each polynomial. That means solve. And we want to start by using the factors that they gave us, which right here is x minus 3. So I'm going to start out dividing by that, and then I'm going to find the rest of the factors of this, or zeros or solutions of this polynomial. All right, here we go. So let's go through this process. And if you just stay with me, you'll kind of see how this can be more efficient than long division. All right, so x minus 3, really quickly, x minus 3 is one of the factors. And to find the 0, I set it equal to 0. Add 3 to both sides, and x is equal to 3. Now, some of you guys can do that in your head, and you can do that really quickly. So that means I'm going to use that 3 as one of my answers in an effort to try to simplify and find solutions of this polynomial, which is to the third power, and it's a little bit daunting. All right, so I'm going to get rid of this because some of you can do that in your head. And now I'm going to use that 3. And I'm almost going to do like an upside down division bar. And now I'm going to take the coefficients from each of the terms of the polynomial. That's the number in front of the variable. Now, really important to be able to do this correctly, you got to have this in order from the highest power down to the lowest power. All right, so that's what I've got here. 1, negative 1, negative 14, and 24. All right, so I'm going to leave some space here. Bring down my first number. 1 is just what I start with. And now I'm going to multiply by that factor, or by that 0 rather, that's up there in the box. So 1 times 3 is 3, and now I'm going to add these together. So negative 1 times 3 is positive 2. Now I'm going to do the process again. 2 times 3 is 6. Negative 14 plus 6 is negative 8. And then negative 8 times 3 is negative 24. And when I add those together, I get 0. And when you end with a 0, you know that you've just secured one of the zeros or one of the solutions of that polynomial. So by them getting us started with negative 3, we just confirmed that it was indeed a solution, or x minus 3 rather. So now what I could do is I could take the stuff that's left over, the stuff that's right here, and I can rewrite that as a polynomial that I can solve at this point. So I'm going to rewrite this as x squared plus 2x minus 8 equals 0, because I'm looking for the rest of the solutions. This is a degree 3 or a cubic polynomial, so I should have 3 answers. I know that 3 is one of my answers. I'm looking for the other 2. So I've got this quadratic here, and I can solve that in the ways that I've been solving quadratics, but I've got one of the solutions to make me be able to simplify and to have a lesser polynomial that I actually do know how to solve. So my solving process, I could use the quadratic formula. I can use the factoring methods that I know, including the trinomials with grouping or completing the square. But I'm just going to jump straight to the quadratic formula because I know that that's going to work every single time. This is my A value, this is my B value, this is my C value. So the quadratic formula is going to be the opposite of B, so opposite of B, plus or minus square root, B squared, so that's 2 squared, minus 4 times A, which is 1, C, which is negative 8, and all of that is over 2 times my A value. Okay? Now, I've got negative 2 plus or minus the square root. Now, what I'm going to do with this underneath the square root is I'm just going to simplify that at first, and then I'm going to kind of work my way from the inside out. So, negative 4 times negative 8 is positive 32. So 4 plus 32 gives me a really nice number, 36. Now, the reason that's really nice is I know the square root of 36, and it's 6. So I could continue to simplify as negative 2 plus or minus 6 over 2. Now I'm ready to split into my two scenarios. That's negative 2 plus 6 over 2 and negative 2 minus 6 over 2. So negative 2 plus 6 is 4, divided by 2 is 2, and negative 2 minus 6 is negative 8, divided by 2 is negative 4. So my other solutions are 2 and negative 4. So all of the zeros for this polynomial, x cubed minus x squared minus 14x plus 24, were 3, 2, and 4. All right, let's do that process one more time just so you can see it happen. We're going to slide down here to something like number 3, or I'm sorry, number 4. We'll do that so we have some different numbers involved. All right, so I've got, remember, x minus 6 indicates that I'm going to have a 6 to start with, and then again, make sure that I'm in standard form and use my coefficients only. 1, negative 6, 25, negative 150. And let's do our process. Bring down my 1. 1 times 6 is 6. Now you add those together and I get a 0. What's 0 times 6? 0. Add those together, you get a 25. 25 times 6 is 150. Add those together, you get a 0. And again, we've guaranteed that x minus 6 is one of my factors and 6 is one of my solutions. So now what I want to do is I want to turn what I've got here into a quadratic. So that's going to give me x squared plus 0x plus 25 equals 0 in order to solve. So now I need to go ahead and recognize that this is x squared plus 0x plus 25, or simply x squared plus 25 equals 0. Now, that's not a nice factoring scenario for me. That's not the difference of squares, so I don't have a nice pattern. And unfortunately, I'm kind of left just to solve this traditionally. It's not going to factor for me, so I'm going to go ahead and subtract 25 from both sides. And I get x squared is equal to negative 25. And some of you are starting to sense how this is going to be a little bit of a headache. How do I get rid of a x squared? I take the square root of both sides. And now those cancel, which is great, but I've got plus or minus whatever the square root of negative 25 is. Now, a negative underneath the radical, that's going to bring I into it, because the square root, keep in mind that the square root of negative 25 is the square root of negative 1 times the square root of 25. Well, the square root of negative 1 is I, and the square root of 25 was 5. So you multiply those together, you get 5i. So I have plus or minus 5i as my other two zeros that go along with 6. Okay? Now, one of the things that's important is for me to find the scenario for you guys that leaves out some of our numbers. So I'm going to get you set up for one of those, and we're going to keep it moving.